Listen, that low rumble, that's not a movie sound effect. That is a real recording from deep under the ocean. I'm Riley Rush, and today we're diving into 10 of the creepiest, loudest, most head-scratching ocean sounds ever caught by scientists. Welcome back to Crazy Top 10. I used to chase storms with a mic the size of my arm, but nothing, and I mean nothing, hits like a bass note born 1,000 miles offshore. Here's the deal. In the deep, light dies fast, but sound goes far. Scientists drop underwater microphones called hydrophones, and huge listening nets like NOAA's arrays can hear booms and moans from thousands of miles away. Earthquakes, ice cracking, whales chatting, most noises are normal. But now and then, a signal shows up that doesn't fit the pattern. It gets a nickname, like Bloop or Julia, and the hunt begins. Tonight, I'll play short clips or show spectrograms, build the mystery, and then give the simplest, best reason science has right now. Some are solved. Some still poke at your brain. And yes, a few were so loud they lit up sensors more than 5,000 kilometers apart. Which one will creep you out the most? Drop your guess now, and let's count down from number 10. Quack, quack, quack. Submariners swore the ocean was mocking them. For decades in Antarctic waters, hydrophones picked up a weird cartoon duck rhythm. No one could match it. Not a ship, not an iceberg. It became a legend, the bioduck. Here's what made it so odd. The pattern came in tight bursts, like a rubbery squeak, and it popped up under sea ice where signals bounce and echo. When I first heard a slowed clip, I laughed. It sounded like a bath toy. Then I learned subs logged this sound since the 1960s. Imagine sitting in a silent steel tube and hearing a phantom duck at 300 meters. Hard pass. The reveal took clever tagging. A research team hooked small recorders on Antarctic minke whales, and boom, their calls matched the bioduck's exact rhythm and pitch. Mystery solved. A whale with a goofy ringtone. Simple reason, it's communication. Minke whales can make rapid, pulsed calls that carry through ice-clogged water. Takeaway, even the silliest ocean mystery can be a smart animal doing its thing. And when you hear a quack in the abyss, it's probably not a prank, just a minke saying hello. On to number 9. This one hits the feels. Since 1989, listening nets have tracked a whale-like call at 52 hertz, higher than blue whales, different from fin whales. No one has ever seen the singer. People called it the loneliest whale. I remember the first spectrogram I saw, one bright line, steady, marching across seasons. It felt like a heartbeat. So what is it? The sound shows up in places whales travel, and it moves like a living animal, migrating year to year. But it doesn't match any known whale voice exactly. That sparked every theory, a hybrid, a unique individual, even a whale with a quirky vocal tract. Here's the science. Frequency alone doesn't prove it's alone. Whales hear across ranges, and they don't need to sing the exact same note to talk. Best simple reason, it's probably a baleen whale with unusual anatomy or a one-off voice, not a new species. Still, with no confirmed sighting, the identity stays open. And that's the magic. One pure tone, 3 decades of mystery. Would you follow that signal across an ocean if you could? Number 8 is stranger because it sounds like a sci-fi laser. If R2-D2 went snorkeling, it would sound like this. Researchers in the Western Pacific picked up a 5-part twang, a quick whoop that drops, then rises, like a bent guitar string underwater. I heard the clip in a lab once and blurted out, "Okay, who smuggled a synthesizer onto the boat?" At first, the biotwang didn't line up with known whale songs or ship noise. It showed up day and night, across seasons, and came from deep water near trenches. That narrowed the suspects. Ships don't sing scales like that. Ice is rare in those latitudes, and fish usually don't blast tones that low and strong. Tagging studies gave the clue. Similar pulse shapes turned up on recordings from minke whales. The timing and energy fit a whale call more than geology. Best simple reason, it's a minke whale vocal style we hadn't cataloged before. Whales have regional accents, and this was a new one. Lesson learned, the ocean's playlist is bigger than we thought. When you map a new place, you hear a new voice. File the biotwang under once mysterious, now mostly whale. Ready for number 7? It's a sound that lives up to its name. Meat whistle. NOAA's hydrophones caught a clean rising tone, like a tea kettle far away, building then fading. Simple shape, big puzzle. I love this one because it looks so neat on a spectrogram, like someone drew a gentle slope with a ruler. Why is it tricky? Lots of things can sweep upward. Gas bubbles from vents can chirp. Lava moving under the seafloor can hiss. Even big groups of shrimp can make a chorus that fools you at scale. But Whistle didn't come with a smoking gun volcano, and it wasn't pinned to a ship lane. It just appeared seasonally, then went quiet. Best simple reason right now, a natural source with changing flow, likely volcanic or hydrothermal activity in the Pacific that turns on and off, making that tidy rise. No hard ID yet, so it's still officially unexplained. And that's okay. Not every mystery needs a monster. Sometimes the kettle sings, because hot water moves underground. Keep that shape in your head, because number 6 trades neat for noisy. Imagine a freight train, underwater. Close your eyes and you'll swear it's a locomotive. Rhythmic chugs, steady spacing, rolling for minutes. Scientists dubbed it train because, well, that's exactly what it sounds like. The first time I heard it, I checked if someone left a metronome on in the edit bay. Train shows up across long distances and doesn't match any single ship signature. That matters. Real ships change pitch and rhythm as they turn slow or hit waves. Train keeps its beat. Could it be biology? Some whales pulse, but this has a more mechanical regularity. Could it be geology? Repeating quakes can thump in patterns if fluid is moving through cracks. Best simple reason, a natural, repeating process. Think pressurized fluids in the crust creating a drumbeat that travels, or resonance in a long, echo-friendly seafloor. There's also a chance of distant machinery coupling into the water, but no confirmed source. Officially, it's unexplained. And it's a great reminder, the ocean loves rhythms, your heart, the waves, and sometimes the seafloor itself. Next up, number 5 slows everything down. Literally, it's named for what it does. Picture a giant hand on a record player, turning the dial, and the pitch droops for days. That's slow down. In 1997, a long signal started at a higher frequency and steadily slid lower over about a week, then vanished. I heard a sped-up version and felt my shoulders drop with it, so weirdly satisfying and creepy. What could fall in pitch for days? Not a whale. Animals don't hold one note that long. Not a passing ship. That would wobble, not glide. The smart money moved to ice. A massive iceberg grinding along the seafloor or cracking in stages can release energy that changes as the contact area grows and the motion stalls. Best simple reason, ice dynamics. A large Antarctic iceberg likely hit shallow ground and slowed as it scraped, shifting the sound lower and lower until it stopped. The timing and location fit known drift paths. Officially, it's unidentified, but ice checks the most boxes. Slow down taught me this. The ocean can sound like a living thing, even when it's just physics. And if you like that, number 4 is its moaning cousin. Longer, louder, and heard across an ocean. Say Hello to Julia, recorded March 1st, 1999. It's a deep, drawn-out moan that lasted about 2 minutes and 43 seconds and rang across NOAA's entire Pacific array. That scale is wild. Sensors thousands of kilometers apart heard the same voice. I remember seeing the map of detections and thinking, whatever that is, it's big. Early guesses flew. A giant creature? A secret machine? But the clues pointed south, toward Antarctica. The power, the low frequency, and the timing all matched a massive iceberg getting stuck or breaking apart. When a block of ice the size of a city shifts, it acts like a drum, and the ocean is the speaker. Best simple reason, an Antarctic iceberg grounding and groaning as it moves. Similar moans have been recorded when icebergs collide or rub on the seafloor. No official 100% tag, but it's the cleanest fit. Julia is a mood, heavy, ancient, and oddly sad. It also foreshadows our number 1. But first, number 3, a sound that kept showing up for years, getting fainter, and still refuses to explain itself. Upsweep is the ocean's weirdest alarm clock. First detected in 1991, it's a series of narrow bands that sweep upward in frequency, repeating over and over in long strings. It spikes in some seasons, dips in others, and has slowly faded across the decades. The first time I saw the spectrogram, it looked like a set of stairs to nowhere. So, what stair builder makes sound? The best suspects live where seafloor meets fire. Submarine volcanoes and hydrothermal vents. As fluids heat, pressure changes, and bubbles and cracks can sing. That would explain the seasonal pattern. Ocean circulation and temperature shifts can modulate venting. Best simple reason, volcanic or hydrothermal activity in the equatorial Pacific, creating those rising sweeps. turning on like a factory line and then powering down. The exact site not nailed. Upsweep remains officially unexplained, but strongly geologic. I love that. It's like the Earth practicing scales underwater. And it sets the stage for number 2, one that fooled navies and scientists for years before a whale took a bow. Boing is the ocean's practical joker. Naval listeners in the North Pacific reported a springtime boing boing tone since the mid-20th century. No engine matched it. It came in bursts, rubbery and bright. If you've ever stretched a balloon and let it squeal, that's the vibe. For years, people argued fish, sonar artifact, secret tech. Then tags and close-range mics finally caught the culprits in the act. Minke whales. Their vocal organs can channel air in ways that make surprising tones, from boings to knocks to the bioduck quacks we met at number 10. Best simple reason, it's a whale call used in seasonal behavior, likely courtship or contact. The reason it fooled us? Range and repetition. A lot of minks calling in a good sound channel can feel mechanical and huge. I like to think of boing as the ocean teaching us humility. We love big, spooky answers. Often, nature gives us a whale with a weird instrument. And that brings us to number 1, the loudest legend of them all. If ocean mysteries had a superstar, it's the Bloop. Summer of 1997, NOAA hydrophones caught an ultra-low rumble that rose fast in pitch, lasted about a minute, and was so powerful it was heard by sensors more than 5,000 kilometers apart. Early spectrograms looked a little like a living call, and it was way louder than any known animal. Cue the monster theories. I get it. The first time I heard the sped-up clip, my brain yelled, "Creature!" But then the science stacked up. The frequency pattern, how it bends and swells, matched known icequakes. Think glacier or iceberg cracking, flexing, and snapping. In 2008, when a giant Antarctic iceberg called A53A broke apart, hydrophones recorded sounds with the same signature. That was the aha. Best simple reason, a massive chunk of Antarctic ice calving and fracturing, broadcasting a bass roar across the ocean's natural sound channels. No Leviathan, just physics at a giant scale. And honestly, that's even cooler. The only monster here was a monster iceberg. The Bloop went from nightmare to nature lesson. Which brings us full circle to why we listen at all. 10 strange voices from the deep, and most of them point to ice, rock, and animals doing their thing. I love that. The ocean whispers and booms, and our job is to ask the right questions, then test the simple reasons first. From the goofy bioduck to the mighty Bloop, science shaved the fear off the unknown and left us with wonder. Your turn. Which sound creeped you out the most and why? Was it the long moan of Julia, the steady train, or the lonely 52 Hz call? Drop your pick in the comments. And if you want more real recordings, fast facts, and big reveals, hit subscribe and ring the bell so you don't miss the next dive. This is Crazy Top 10, and I'm Riley Rush, signing off with one last thought. The ocean isn't silent. It's a story we're still hearing for the first time. Thanks for watching, and hey, if you learned something, give this a like and share it with your favorite ocean nerd. I'll see you in the next countdown.